done. The recording can be done. Okay. Thank you for joining again. Uh, where I was. Let me share the screen. See. Okay. It's fine. It's fine. So from it, from this, can you solve some problem based on that? Where is the my center of mass coordinates? Jai Charan, Jai Chandan. Sorry, I can call you Jai. Jaya. Sorry, Jaya. Can you solve some problem based on this center of mass coordinates? Okay, thank you. And then, so here also another term. Okay, similarly, how can we write the R equals to, based on this center of mass equation, RE, ME, RE plus MN, RN divided by M of E plus M of N. Okay, so these equations are important during your exams. So we can find some problems based on this equation. So you just know everything from your class 10 plus 2 level, and then you can write it. Okay, so now based on these coordinates, we can write something called reduced mass. It will come in the later part. Okay, so now my hydrogen atom equation becomes, has a two part. One is the my nuclear part, another is the electrons. So nucleus is heavier than my electrons. So here comes some new approximation, right? So in that case, so my initial equation is this. Hamiltonian operator is the H psi. This is the H psi for the hydrogen atom. This operator has a nuclear term and my electron term. So in that case, right now we can write this, separating out this nuclear term and the electron term as a from the operator. So it is H psi square minus of 2m. M is the, let's suppose we are talking about the mass of the nucleus, and here is the R of the new coordinate system, and the mass is the new mass of the nucleus. So after the change in coordinates, and then we have a square cross by 2 mu. Mu is the reduced mass of the electron, and q z is square by r is the another term. Okay, and then it will function on psi of total. This psi total again split into some other parts. One is the nuclear part, another is the electron part. Okay, E of total and psi of total. Here M is equals to M of E plus M of a nucleus, and here mu equals to M E N M N divided by M of E plus M of N. So this is called reduced mass. As you know, this is called total mass. total mass and reduced mass. So everything is covered in physics 10 plus 2 level. I think so. So it is super easy. Then here is the another problem coming out of it is that while we are solving the problems of the hydrogen atom based on the Cartesian coordinate system. Now, our goal is to separate this function, right? So this psi total becomes the nuclear function. Let's suppose we call this psi of n and psi of e. Okay, and e total here also e total becomes e of n plus e of e. We're taking it as a initial guess where the and also here my Hamiltonian operator H separated into two terms. One is the nuclear term plus Hamiltonian operator for the electron term. Right? Now we know En equals to H cross K by 2m. Whether all the nuclear, it is the potential energy. No, sorry. It is the kinetic energy. En. It is the kinetic energy for the nucleus. Is solving this nuclear term into this, taking a psi m, and then we will get some other. This is for the nucleus. Now we have to solve the electrons. Solving for electrons. How it will be? My H of E electron psi E equals to H cross by 2 mu del square R minus Q Z E square by R, which is function on psi of E, and it giving us E of E into psi of E, right? Then this psi has some coordinates with the x, y, z. So psi is a function of x, y, z, and the del square r. This del square r is del 2 by del x square plus del 2 by del, this is not the d, del y square plus del 2 by del z square, right? From these we can generate something called this h psi h of e psi e equals to minus h cross by 2 mu into del 2 by del x square plus del 2 by del y square plus del 2 by del z square into this operation the psi x y z e minus of, this is the term u z v square square root of, this is r equals to, initially we told that this is the r is the r equals to x square plus y square plus z square. So this is x square plus y square plus z square, and this equals to energy E of psi of x, y, z. Oh, it's operated on the psi of that y, z. Okay. Now problem is that this term can be solvable by taking that psi 1 psi x is the equals psi x y z equals to psi x psi y psi z, separating out the variables, but this term cannot be separable. So this is not separable. Not so we need another way. We have to find out another way to solve this equation. So here comes the polar coordinate system. So as we know the polar coordinate system, so this is, you can write polar coordinate system in a different way. This is the x, y, z. We have a r, this r, this called r theta phi. We all know from the 10 plus 2 level. This z axis, this is the phi, and this is the projection of that. This is the projection. So this is the phi. This is the phi. Sorry, this is phi. So we have oh, this is phi. This is theta. Sorry, this is theta. So we have the z equals to r cos theta, right? Y equals to, we have a projection. This projection is that r sine theta, right? So this position is r sine theta and followed by sine phi. Y equals to r sine theta. Sorry, r sine theta, sine phi. X equals to, similarly x equals to r sine theta cos phi. Okay, and followed by a volume element is called d tau. D tau is defined by r square dr sine theta d theta d phi. Okay, this volume element, actually it is coming from Cartesian to polar coordinate transformation. This term always comes. Now, in our equation, if you put all together in that equation, it is giving us some lengthy equation. This is, we don't need to remind or remember these things. It will always be given in any problem. So if you put into all coordinates in terms of the r theta phi, it will giving us some Hamiltonian operator h psi, which is given by, is like minus h cross y 2 mu 1 by r square del r into r square del psi e by del r. So this is giving us the del 2 by del r term, and plus 1 by r square sine theta d theta into sine theta del psi e phi del theta plus 1 by r square sine square theta to divide a del 2 psi e by del phi square. This is the one term, the potential energy term. Now we have uh, another term is the this is the kinetic energy term. Here is the potential energy term. We have the q z e square, this x square y root over of x square y square plus z square. It becomes right now r, and we have a psi e to e of psi e. So after separation of the all the variables, we have some equations. Coming out of it is the final one will be the let me check. Yes, the separation with the separation of variable with the separation constant, with a separation constant is beta, then it will be defined by r term and the theta phi term will be separable, and then it becomes the r del r square del r by del r smaller. This r is the radial function, as the psi can be defined as r theta and the phi. These are here the radial part, here is the theta part, here is the phi part. So based on that, this r is the radial function. In a short term, we are writing the capital R. Okay. So which is plus 2 mu r q z e square y h cross square plus 2 mu r square y h cross e equals to beta, and followed by the theta phi part. So that will be 1 by theta into 1 by sine of theta del theta sine of sine theta into del is the theta, capital theta by del theta plus 1 by 5 into sine square theta del 2 phi capital phi by del phi. Okay, equals to minus of beta. These two terms, again, here is the theta term and the phi term. It can be easily separable. So after that, you can angular equation, you can separate it out, and after that you will find the 1 by 5 del square phi del phi square give me minus f square. Okay, So this m is called magnetic quantum number. This term is not hypothesized, it is actually coming from the derivation of the to solve the atom problem. It's completely mathematical term initially, and then they interpret this magnetic quantum number into this m term into a magnetic quantum number. Okay, so in finally, after theta solving the theta part, they found uh, the equation is 1 by for the radial part. In the next page, let's suppose in the next page. In the next page, we have a separate part. One is the radial part. The radial part is that 1 by r till del r square till r. This is the radial part. Now we have a angular part, two part of the angular part. One is the theta part. Theta part, it will looks like sine theta by theta, capital theta, and we have a del theta into sine of theta to del theta, capital theta. This theta is the function as a theta function, and with respect to the theta plus beta sine square theta equals to n. Okay, and then the phi part will be looks like 1 by phi del square phi by del phi square equals to minus m square. Okay, this is the this phi is completely this three part is the radial part, theta part, and the phi part. Actually separable, and it is separated. Okay, now here try to solve this theta and m part and this theta part. Here comes some parts. Now some this initially they solving the this equation phi solving phi equation will get e to the power I m phi into oh no uh, solving this equation. We first of all we have to know that the phi part. The trial solution will be something called phi of will be it's completely trial solution. It's called a to the power I m phi. This is the function trial function. and we supposed to operate on that equation, and then we will find out the actual function. So if you operate it, before operating, we have to some postulate on that, that we have a, let's suppose we have a one, this is the phi, and this is the axis xy plane. As it is in xy plane. This is x and this is y, and this angle is the phi. If it is giving some boundary condition, this is after 2 pi rotation, it will giving the same value. So that means my this phi will be the 2 pi plus phi equals to psi of phi. Sorry, this is capital phi, small phi. Okay, this is the condition, and as it is single value. If it is single valued wave function, 2 pi plus phi give me the same function of the phi, right? So then we can add some slides. Now my phi here is the phi equals to, assumption is the e to the power I mf phi. So this phi 2 pi plus phi to phi of phi, right? And then we will implies on that, it will give me a into e to the power 2 pi plus im will be outside, e to the power 2 pi plus pi plus 2 a into e to the power im phi. So it will give us like that, a into e to the power 2 pi im and e to the power im phi a to the power im phi. So I am phi, if you are I am phi, if will neglect each other, a neglect each other, that means it will give us e to the power 2 pi I m equals to 1, right? So 2 pi cannot be 1, so that means we can say this is can be 0, then it equation valid. So here if it is 0, so we can say I m equals to 0. So that means uh, this equation can valid, and then we will miss all the information. Now here is a one smart technique. It's called this 2 pi im can be written as cos of 2 pi m plus minus I of I of sine 2 pi, sorry, 2 pi. Okay. So from here you can, this one equals to 1. So that means this right hand side is the real value. So this imaginary part should be, it implies this should be 0. So our case is that cos of 2 pi m equals to 1. When this cos 2 pi m equals to 1, when m equals to 1, 0, plus minus 1, plus minus 2, dot, 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 dot. Right? Here is the comes the point. 2 if is okay. So okay. So then, okay, thank you. Uh, then this m value can be, your m equals can be 0, plus minus 1, plus minus 2, and plus minus 3, dot, dot, dot. Right? So this pi equation, so now this pi equation can be what will it denotes, is actually denotes the circular motion. It denotes the circular motion in xy plane, right? If it is circular motion in xy plane, x or y, it is x, sorry. That means still giving us the z component of z, will giving us the z component of angular momentum. Okay. How can you prove that? It is a z component of the angular momentum. Let's operate this phi onto the angular momentum operator. So this is the Lz of 1 by operator. What is the operator? Z by I into del phi. And it's operate. This is the operator. And it will operate on the phi operator. Phi equals to phi of a function of phi equals to a into e to the power I m phi. Right? If you operate it, it will give you, what it will give you? And you put all those. So Lz phi. What will be? It will be H cross by I and del phi into AF e to the power IM phi means equals to H cross by I, here I M, and we have it is over IM phi, right? That means this I cancel each other and we will get, sorry, this is not the H cross square, it is the H cross only. This H cross M A e to the power IM phi. That means this H cross M phi, phi, right? So this is the eigenvalue of this LZ operator. That means this is the function. This phi function is the function, eigenfunction of LZ operator. That means phi actually includes the angular momentum at the z axis, along the z axis, right? Okay, fine. I think so. Then we most importantly able to know that this M give us 0 plus minus 1 plus minus 2 plus minus 3 dot 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 dot, and this M is called magnetic. If any charge particle moving around any circular motion, it will give you the magnetic field, right? So this M includes in a phi. Phi is the angular momentum along the z-axis component. So that means this M actually includes in a some quantum number which controls the magnetic field. So that's why we are saying it is the magnetic quantum number. It is actually coming from, not actually coming from the classical mechanics. It's actually coming from the quantum mechanics. Okay. And this M always be greater or equals less or equals L. This M value always is the mod of M. I'm sorry about my handwriting. So mod of M less or equals to L. This L equals to for azimuthal quantum number. So in the initial days in class 11, I think you are well known about that. We have a principal quantum number A, we have a azimuthal quantum number L, and we have another quantum number, magnetic quantum number, which is called L, and another is called spin quantum number. Spin is not included in that course, but spin always comes in a later part. If you want to follow the lecture series from the Professor Anindra Datta from Quantum Mechanics NPTEL course, you will find it in a YouTube video. You will definitely get that the spin part into that course. So it is out of your syllabus. I think it's better to restrict with the N, L, and M. Okay. So and we have solving the theta part. Now solving theta part. Theta part. You will get something called theta of theta. The function of theta, it is called something integer, some constant, and some polynomial. This is named the legendary polynomials m, which is m cos of theta. This is the final version, and we have this p has a some distinct value. This p equals to actually minus of 1 for m l minus m by l plus m of factorial, and this one is factorial, and this sorry, in a wrong. This p is equals to something polynomial p cos theta, yeah, l cos theta minus 1 for l factorial, so 1 minus cos square theta m by 2 2 by 2 into t t l plus m t x square l plus m cos square theta minus 1 over l. Okay, this PL is called f cos theta. This is called associated legendary polynomial. And L is called L. Initially, we already written L will always be 0, 1, 2, 3. Here also M always less or equals to. Okay, so it can be proved. So we'll try to, can you find the if can L cannot be greater than L. You follow the lecture series from the Professor Datta and then try to find it. Okay, so it's not a very tough equation. We will have some polynomial equation, and then we have to solve this equation, and we will get the value. Okay, so we have the angular momentum theta phi part, and first of all, and then final, we will get something called angular momentum. With combining together, we have called angular momentum operator. It is called L square theta. Is if it is operates on something called function of theta and phi will give us H cross L of L plus 1 and Y of theta phi. Okay. So in finally we'll get this equation. Based on that equation, we'll try to solve some problems. Okay. And also, yes, sorry, there is a radial distribution part term solving the radial distribution part. R of NL. N is the principal quantum number based on coming from the solving this radial distribution part. R of NL, it is actually denoting Y minus of something, or N equals N minus L minus 1 factorial, and then we have 2n into n plus L factorial, and it will be Q whole cube. It's a long term. You have a square root, and we have a 2a 0 n. A0 is the uh, value of uh, a is the value of your reduced mass, and we have L plus 3 by 2 and r to the power L e to the power minus r by n a0 into L legendary polynomial. We have a n plus 1 to 2L plus 2 1 minus 1. Sorry, this is actually coming from the boundary condition 2r into n of a0. You don't need to solve this r function. It is a higher mathematical part. So just you guys, you have provided some equation. Based on that, you supposed to just solve your problem. That's all. You just understand that the theta, solving the theta phi is phi, and phi is very easy. You can do yourself. Theta and the r, here introduce some polynomial, and based on that polynomial we will get the some equation of the r and theta function. Okay, so that's all, and after that you can solve some problem. You have some problem uh, in my store. We have few problems. Let's introduce one problem. The next page. Okay. Step. Okay. The problem is, I'll give you all the equations. Here is the table 1, and let's solve the problem. Okay. Okay. Can you solve? Can you prove that? So that the hydrogen-like atomic wave function of psi 2 1. Psi 2 1 means this is the psi 2 1. The wave function is the 1 upon square root of 32 pi z 3 by 2 y a sigma a sigma, and this is the function only, and e to the power sigma by 2 cos theta, right? And based on that, here is the a is the Bohr radius, is the radial distribution function, right? And based on that, you can solve that this psi 200 is can be normalizable. Psi 200 is orthogonal to psi 210. Can you prove that? Yeah. What is the condition for the orthogonality and the normalizability? Normalize? Okay. Uh, Condition for the normalizability, it is psi of 210 psi of 210 uh, bra psi 210 and ket psi 210, it will be 1. This is the normalizability. Normalizability, and orthogonality will be psi of 210 bra psi 210 and ket 200 give you the 0. This is the orthogonal condition. Can I prove it? The given equation is given here. Psi 210 given here, psi 200 given here. Based on that, can we prove that psi 200, psi 210 is a normalized one, normalized function, and psi 210 is orthogonal to psi 210. Okay, let's see. Okay, first of all, our normalizability. Psi of 210 plus psi 10 get psi 210. Okay, what does it mean? It does it mean 0 to infinity d dr square. Oh, what I write? Psi of 210 psi of 210 d job will give you value. It's supposed to be 1. If it is 1, then it is normalized. Okay, now proving it. Now we know the site 10 value. Based on that, we'll write infinity dr r square. We have 0 to pi. All the boundary condition we are using: d theta, sine theta. We have 0 to 2 pi, d phi, and followed by the equation is the 1 by 3 2 pi, and we have z by a0 3 by 2 sigma e to the power sigma or minus sigma by 2 cos theta and whole square. Okay, now it is this term coming out of it. This is the term square term. It will give you 1 by 3 2 pi z, sorry, z by a0 whole to the power 5 into 0 to infinity d dr again so it's r square, sorry, r to the power 4 to the power minus j r by a0 0 to pi d theta sine theta cos square theta into pi d phi. It will give you 1 by 3 2 pi z pi by a0 2 pi 2 pi uh, 2 pi 2 pi 3, 2 by 3 followed by will give you the a0 by z whole to the power 5 and 24 give you 1, and that means all cancel each other, and finally will give you 1. So psi of 210 is normalized. lots of step has been skipped. So we'll try yourself. Then you'll get that. The A0 is always associated with the R value. So similarly, can you prove the orthogonality part? Can you do that? Yeah. Just add those equation in in the orthogonality. It will be looks like your psi of 210 0 0. That means we'll have 0 to infinity psi of 20210 and star psi of 200 tau d tau. Put those equations and find out what is the value of this integration. Can you do it yourself? If not, then try to solve from some what is that? Some support from Google or some books. Try to solve it. This kind of problems you will find in the exam if in future if you need it. Okay. So next day I'll again I'll bring some problems based on the hydrogen atom problem and hydrogen. Okay, thank you, Jan. Next day I will also bring some problems, and then first of all in the initial time I'll solve those problems, and then I will give you some homework uh, to solve those problems based on whatever we solve in that lecture, in not lecture, in that problem solving session. And then I will cover it up the some molecular orbital theories part. Okay, and then we'll discuss the any problems whatever you find in some literature or some question paper and some anything whatever. You just give me some problems. So I will try to, if I am not instantly solve that problem in future, I will definitely in the next session I will try to solve that. Okay. Thank you, Jia, for joining this session. I'll stopping here, and I think in the next weekend I will also again come back and discuss something. Okay, some problems. Right? Okay. Thank you. Bye bye. I'm stopping here.